Cool. So, hello everyone. Good afternoon. Thanks for coming. Today we share some insights, challenges, and learnings that Cheesecake Labs had developing non-custodial wallets on the Stellar network. Uh, yeah, this is the title. I'm Bruno. I'm a software architect here at Cheesecake. And Cheesecake is a Brazilian-based company that develops projects for Web 2 and also Web 3. We are Stellar integration partners, so we have a lot of projects within the Stellar network, such as digital wallets, that's what I'm going to talk about today, asset tokenization, smart contracts, and much others. One of our biggest use cases was the MoneyGram non-custodial wallet that was announced in the last Meridian, where we partnered with the MoneyGram to build this wallet that integrates with their existing on- and off-ramp solution, and also to send money to users using USDC. We also partnered with STF to build the Vibrant wallet that helped Argentinians during high inflation times by safeguarding their money on other currency. And also outside the context of wallets, but talking about asset tokenization, we also partnered with the biggest cryptocurrency exchange in Latin America, which is the Mercado Bitcoin, where we built the asset sandbox, where some of you may have heard of. That is a platform for building and managing assets. So when we're talking about digital wallets, there are mainly two approaches, right? The first of them is the custodial or traditional wallets. And in this approach, third-party providers, banks or exchanges, or even the company that is building the wallet is holding the user secret key. So this can potentially simplify the flow because the company is operating the money for the user, but there are some risks and challenges as well. So one of the challenges or risks is if the company goes like bankruptcy or there's some like cyber attack, since the company is holding the user secret key, this can be potentially dangerous. And also there's some compliance issues around custodial wallets because, for example, you are operating with the user money, right? So in the United States, for example, you may need to have a money transmitter license, which can be a challenge for companies that want to build custodial wallets. And what are non-custodial wallets? So non-custodial wallets, as the name suggests, the user has fully control over their secret key and assets. This has some advantages because it's more secure. The user is in possession of their secret key. But there are some challenges as well because when we're talking non-custodial, the main challenges is key recovery. So Stellar has this awesome standard, which is the SEP30 that I'll talk about later, that enables key recovery on non-custodial wallets. So Cheesecake has been developing wallets for the past few years, and I think we have developed 3 wallets, I guess. So we faced a lot of challenges, and they are very similar. So in these 3 projects, we faced similar challenges. So I have 3 of them for today. The first of them is the key storage and recovery. Since we are building non-custodial wallets, we cannot store the user secret key on the backend or a server. So we need to store the user secret key with the user. So I will share today how we are doing this, and also an overview of the transactional flow, how the mobile side interacts with the backend, and also some key recovery options with SEP30 and also SEP5. We faced some usability issues, and this is more on the product design side, because, for example, the MoneyGram users is not familiar with crypto at all. So we had some challenges on how to name features and how to develop the UI. And also anchors integration. So during this time, we did a lot of anchor integrations using SEP6 and also SEP24. And I will share some challenges that we faced with these SEPs. So the first challenge is key storage, right? So as I said, we are developing non-custodial wallets. We cannot store the user secret key on the backend or on the server. We need to store with the user. So we did some benchmarks on how we can do this, and we landed on use the Apple keychain and the Android sharing preferences, which are native solutions from mobile applications. So in that way, the user secret key is encrypted on the user's mobile device, which then makes it non-custodial, and also can protect against malicious applications or malicious users that tries to get the user secret key. And with this approach, there's no transmission of the secret key between the mobile side and the backend. And here I have a very basic diagram that explains how this works. But basically, on the left, I have this blue device and this red key, which represents the mobile application, and the red key is the secret key of the user that is stored on the device. And on the right side, I have the backend or the server. And how this communication works. So basically, the mobile requests a transaction for the backend. the backend will build this transaction and returns for the mobile in the XDR format, which is the standard Stellar transaction encoding format. Then the mobile will verify the XDR integrity, because let's say that the transaction was intercepted in the middle and there is a malicious XDR going on. So we need to verify if the XDR is valid. It's really the transaction that the user wants to do. If it's correct, then we sign the XDR with the user's secret key, which again is stored on the user's device. So after that, the mobile will submit this XDR to the backend, and the backend will submit to the Stellar network. So with this approach, the secret key is not being transmitted on the mobile to the backend, and the mobile side really only acts as a signer for the user, and the backend is responsible for building transactions and also submitting them to the network. So talking about key recovery. So Stellar has this awesome standard, which is the SEP30, and this basically provides a way for the user to recover the keys using a multi-signature approach, where the user shares the signature power of their account with 2 or more keys. And it's secure enough because these keys doesn't have enough power to sign operations for the user on their own. They always need to be combined. So I have this diagram that's trying to explain how this setup works. It's kind of complex, so I'll try to explain. We have here a Stellar account on the left. That is really the user account that is on the network. And the total threshold account for this account is 50. So every signing key needs to have at least 50 to sign operations on the user account. So as I showed before, there's this blue device with the weight of 50 that is necessary for signing operations for the user on a daily basis. And there is another 2 keys here that is not stored with the user, but with different servers. So the first of them have a weight of 45, and the second has a weight of 5. So they don't have enough power to sign operations on their own. They always need to be combined. And we need to combine them when the user is performing a key recovery operation on the app to add a new key. So I try to explain how this works. So let's say that the user lost access to the secret key that was stored on their device. And this can happen if the user is logging on in the device or they're logging out on their current session. We need to add a new key, right, for the user to operate. So the user proves their identity with these different recovery signers that holds the signature power on the user account to add a new secret key to their account, which is the yellow one. So basically, the user performs authentication on the app, they remove the old key of their account, and they add a new one, which are basically swapping the keys. And the recovery signers is responsible for doing this operation for us after the user proves their identity. So this is basically how it works. It's really complex, so I can try to explain later on after the talk if you want to know more about it. But this is how we are doing on mostly of the wallets. This approach comes with some challenges because to make it work, we need to host some services like the WebAuth and the recovery signers, which are built by the SDF. And also, we need to find reliable partners to host and maintain these services, right? Because these are 2 different services. One of them usually belongs to the company that is building the wallet, and the other belongs to another company that doesn't have anything to do with the wallet. So finding these partners may be sometimes challenging. Another approach for key recovery, and that's much more simple, it's the SEP5, where it defines a method for generating seed phrases from a secret key. This is a standard on other applications, other cryptocurrency block applications as well. So the seed phrase makes it easier to move accounts to different wallet applications. Another challenge that we faced that was more on the product side was the UI UX. So as I said, MoneyGram, for example, the user doesn't have any familiarity with crypto, so we need to do some tweaks on the UI to make it work for these kind of users, and also to explain how the SEP30 flow works, because it looks kind of different for the end user. The user needs to perform the authentication twice, so I'll share some screenshots example. So this is the MoneyGram non-custodial wallet, and as you can see, this is a basically payment operation, and this operation has 3 to 4 steps where the user inputs the amount of USDC that they want to send to another user. They can put a quick message if they want to, and then they submit to the Stellar network, and on the background is a payment operation going on. So this is how the flow looks like on the MoneyGram non-custodial wallet, and as you can see, doesn't look crypto at all, right? Like, doesn't have anything related to crypto. looks like any other traditional finance application. This was the goal, right? Because these users doesn't know crypto specifically. Also about key recovery. So as I said, the user needs to perform the authentication twice, and this is kind of different from what we are used to on other applications. So what we did is the user performs the authentication one time, then they perform the authentication again with the second entity. This is necessary to make the flow works. And then we have this third screen basically describing what's going to happen. The user lost access on any other device, and we'll add this session on this new device that the user is logging on. So this is how the UI looks like. It's only 3 steps, but on the background, we're doing a lot of things to make this flow works. And talking about anchors integration, right? So we develop a lot of wallets, and in a lot of them, we did a lot of integrations with different anchors. And the SEP6 was the most challenge of them. And SEP6, for those who don't know, is basically a collection of APIs to perform deposit and withdraw operations with anchors. The thing about SEP6 is it's a guide and not a rule as any other SEP. We're talking about anchors, and anchors are banks, and banks may have their specific business rules, right? So on the SEP, SDF did an awesome job trying to represent all of these steps, but it may be kind of tricky because the anchor may have a different KYC provider that takes like days to verify the user identity. So we need to handle this on the wallet side as well. And we learned that communication is the key. So it's crucial to have a communication bridge between the team that is developing the wallet side and the team that is developing on the wallet side to make the integration as smooth as possible. So also we learned that it's crucial to have a sandbox environment pointing to testnet because it's a mess. Testing on mainnet is not recommended at all. And also, as I said, the KYC was our main challenge because, as I said, different anchors may have different KYC processes. So customizing per anchor is often necessary. And here I have a diagram of how the flow looks like in a happy path scenario. So the user starts with the SEP10 authentication, which is basically authentication with their secret key. Then we have the SEP38 quote server to generate a quote for the operation that they are trying to do, deposit or withdraw. Then we have the SEP6, which is the server that really creates a transaction. Then we have the SEP12 KYC verification that performs the user KYC. And after the user goes through everything, if everything is OK, then the user can finalize the transaction. This is the happy path scenario, and it's obviously simplified. There's a lot of things going on each of these boxes. But there's some edge cases, right? So the first of them is the quote expiration. So when we generate quotes, they are valid for a certain period of time. Usually it's like 15 minutes, 10 minutes. So the wallet needs to handle this verification to not submit a transaction that is expired. So one approach that we had was to verify the quote expiration time before each of these steps. So if the user tries to go through the next step and the quote is expired, we generate a new quote on the background for the user and only shows a dialog with the updated values for them. So this is the best experience as possible because the user doesn't need to do anything. We are doing everything for him. And we are only showing the updated values if the quote has changed or not. So this is how we are doing on some of the wallets that we implemented. Another edge case is the KYC verification. As I said, the KYC process may vary from anchor to anchor. So sometimes the anchor takes a long time to answer if the user was approved or not on the KYC process. So what we did was, if the KYC is taking like longer than 15 to 20 seconds, we redirect the user to the home page, like basically saying what we are doing. Their identity was being validated with the anchor. Then we await the anchor SEP12 webhook to say if the user was approved or not. So if the user was rejected, we say why they were rejected and put like some contact information of the anchor. If the user was approved, we can redirect the user to the flow that they were, and we can resume the operation where they stopped it. So this is the best experience as possible because we are recreating everything for the user on the background and only putting them on the flow again after they were approved so they can finish their withdrawal or deposit operation. So these are some of the challenges that we faced on the SEP6. Also, I want to give a special shout out to the wallet SDK that helped us a lot because every one of these methods are implemented on the wallet SDK, and we only need to handle like these crazy edge cases. But yeah, it was really helpful. And another anchor integration is the SEP24, which is basically the same thing as the SEP6, but the UI is made entirely by the anchor. And from a wallet perspective, it's much more simple because the UI is totally made by the anchor, but there are some challenges as well. So depending on the way that the anchor finalizes the transaction, it may be necessary some UI changes on the wallet, for example. So MoneyGram, for example, for the user to finish the transaction, it needs to go through a MoneyGram location. And we need to reflect these on the wallet side as well. So this can impact the UI. And also, as the UI is totally made by the anchor, sometimes it can impact the experience on the app. So let's say that the anchor is using a dark theme and the wallet is totally built in a white theme. It can be kind of shocking for the user because it's totally different colors. So this is one challenge as well. This is how the flow works for the SEP24. As you can see, it's much less boxes. So the user starts with the SEP10 again, do the SEP38, and this is optional because sometimes the SEP38 occurs on the web view itself. The user then starts the SEP24, which returns a URL where the wallet may embed on the application, and then the user performs the transaction within the web view. So as you can see, it's much more simple, and then the wallet only needs to wait for the anchor webhook saying if the transaction was successful or not. So it's much more simple, but again, there may be some edge cases. And as an example of SEP24, we have the MoneyGram access that was mentioned a lot today. As you can see, the UI is totally with the brand of MoneyGram, with the white theme. So usually wallets pick this and embed as a web view on the applications and make the integration much more easier. So yeah, that's it. Here I have a QR code to download the MoneyGram Non-Custodial wallet and also the Vibrant wallet that we helped it to develop. And there's the Cheesecake Labs LinkedIn, so you get all the latest updates. If you want to discuss more about wallets or any other solution, me and my beautiful team will be here for the 3 days. We also have some awesome swags. So yeah, let's connect. Thank you.